Hassler here. All right, so I know that we talked about the quick notes for 2.3, and we had started working through these questions in the Check Your Understanding, but we just didn't get a chance to talk through all of them. And I think it's important that you understand what the notation represents, how to find these slopes of tangent lines, and make these connections. And so I'm going to just run through these quick notes again, make sure that we have all the pieces and parts. And then I'm going to run through and work problem 2, 3, and 4 so that you can be more confident and comfortable when you go to do your 2.3 practice. So we actually talked last week about this idea of if you're given f of x, which is the original function, I'm going to abbreviate, then f prime of x, again, that's read as f prime of x. That little apostrophe there. F prime of x tells me a couple of things, okay? F prime of x gives me the slope of the tangent line to the f function at a specific x value. It tells me the derivative of the function, which again represents the slope of the tangent line to f of x. But it also tells me the instantaneous rate of change and that is the rate at which a function is changing at one point, not the average rate of change, the change between 2 points. Instantaneous rate of change is the rate at which a function is changing at just 1 point. And so f prime of x represents all three of those things, which means all three of those things mean the same thing. We can see this notation as y prime, f prime of x, or g prime of x. We're going to see other notation called Leibniz notation, which is dy dx. So again, dy dx should seem reasonable, right? Slope is change in y over change in x. Delta y, delta x, and so d for delta. Or it can be written so that we say find the derivative d dx of a function. So that y could be dropped down. All different ways to say, hey, find the derivative. Hey, find the slope of the tangent line. Hey, find the rate at which a function is changing at just one particular point, instantaneous rate of change. So we talked about problem 1. I'm not going to go back over that. I want to set up and work through problem 2. We did this quickly in class, and so I want to make sure we have a good foundational understanding so that we can better do problems 3 and 4. So I'm given the g function, g of x equals 4x squared minus 5. It says use the limit definition of a derivative to find g prime of x. Notice it says g prime of x. There's no specific a value or no specific x value, which means that I want to find a generic or a general equation, not a specific number. This is not going to give us a specific number. Okay, and I think we saw that in class, but again, I just want to make sure we understand that process. What we failed to put in class is that g prime of x equals. We just started off by writing that limit definition as h approaches 0. So let's go back into our notes and let's make sure that we write g prime of x is equal to this. Right, we said in our notes up above together in class that to find the equation for a derivative function, to find the equation for the slope of the tangent line, we're doing these limit definitions. So g prime of x is equal to, all right, this limit definition says I have to do 4x squared minus 5 minus, and then again, I'm going to do 4x squared minus 5, and I'm going to do all of that over h. Now, I intentionally set these parentheses here so I can fill in the missing pieces. This definition makes me do a plus h, so f of a plus h minus f of a. Remember, the f is just a placeholder to say use that function given. In this particular case, there's no a value. It just says x. So instead of a plus h, or instead of a specific number plus h, I'm going to write x plus h. If they just ask me for a generic formula or a generic definition or a generic equation, I just use x in that generic equation both times. This is why I can't use the second limit definition, because then I would have the function with x and then the function with x again being subtracted. It wouldn't work. So now I'm going to say equals the limit. This is where I do some expansion. So I have 4 times. If I expand this out, I get x squared plus 2xh plus h squared minus 5. I'm subtracting everything to the right. So I'm going to distribute. I really have a minus 4x squared and then a plus 5, all divided by h. I got to distribute that 4. So limit as h approaches 0, I've got 4x squared plus 8xh plus hx squared. Hopefully you're following along in your notes. I went super fast in class, which is why I'm redoing this. Make sure that you have all the pieces. At this point, I noticed that 4x squared and negative 4x squared cancel. Negative 5 and positive 5 cancel. And I'm left with 2 terms, both of which have h. So I'm going to go ahead and I'm going to factor out that h, which leaves me with an 8x plus h all divided by h. The h's divide out. I can substitute 0 in for this h, and that leaves me with 8x plus 0, which is just 8x. That is g prime of x. As a reminder, g prime represents the slope of the tangent line to g at x. Slope of the tangent line to g at x, okay? Why would I want to have this formula? Well, because in part B, which I super rushed through, in part B, I'm asked to find the instantaneous rate of change, or the slope of the tangent line, at 3 different x values. So either I get to run through this business 3 times for these 3 different x values, or I torture myself only 1 time by finding a generic function for the derivative or slope of the tangent line, and then I can use this generic function for my slope of my tangent line or my instantaneous rate of change, right? Instantaneous rate of change means g prime of x. And once I get this g prime of x formula, I can quickly say, hey, then g prime of negative 3 is equal to 8 times negative 3. So the slope of the tangent line to g at negative 3 is negative 24. And hey, because I have this formula, I can do g prime of, not negative 3. We already did that one. I can do g prime of 5. And g prime of 5 means I'm going to do 8 times 5. And that gives me 40. So the slope of the tangent line to g at x equals 5 is 40. And I can do g prime of 20, which means I'm going to do 8 times 20. So the slope of the tangent line to g at x equals 20 is 160. That's a pretty steep line. The point is, I did those 3 very quickly. Or, again, I could have run through all of this for all 3 of these x's and gotten the same answer. But I really appreciated how quick I was able to do part B because I had this derivative formula to use. Okay, so I hope that helps with the generic x instead of a specific a value. Let's take a look at 3. So 3 says, what does the limit as h approaches 0 of the natural log of e plus h minus 1 all divided by h represent? So first of all, I'm going to look at my options here. And all of my options either have f prime or just f. This limit definition looks an awful lot like the limit as h approaches 0 of f of a plus h minus f of a all over h. That's what it looks like to me. And we said that this is going to be equal to f prime. Right up above in our notes, when we took notes last week, we said, hey, if I'm going to find the derivative of a function, the slope of the tangent line of a function, the instantaneous rate of a function, then I can use this limit definition. The things that look different is this natural log and this 1. But remember, that just means that my function that's being used is natural log. Right? When we see an actual written out expression, like up here, when we see the actual written out expression, we didn't write f of something. We wrote what the actual function was. The actual function was the 4x squared minus 5. So that tells me that my actual function is probably, I'm going to write my actual function, my original function is probably natural log of x. And this second box that gets used is what you get when you evaluate, right? What you get when you evaluate the function for a particular number. The value that is in the blank plus h spot, this value in the blank plus h spot, that's my a value. So I bet a is e. That's a number. Remember, that's about 2.7128, blah, blah, blah. Okay? So this kind of feels like to me that I have a function f, it's natural log of x. By the way, if I do f of e, so natural log of e, that's equal to 1. So that makes sense for this value here. It looks to me like I'm trying to find then f prime of e, that's my a value, f prime of e, where my function is the natural log function and the specific x value is e. Let's see if that option is here. A reads, I'm trying to find f prime of e, that's my specific x value, where the original function is natural log. Yeah, actually, that feels pretty good. I'm going to circle that one. This says find f prime of e, yeah, where the function's natural log of x divided by x. No, that's not right, or else I would see up here that reflection of natural log of e plus h divided by e plus h, and I don't see that. F prime of 1, no, because my a value is e and not 1. F of e, no, because this is a limit definition. I'm trying to find a derivative in f prime. And f prime of 0, no, because my specific x value I'm looking at is e. So A was the right answer. So yeah, you're going to be expected to look at a limit definition and pull the function out of that limit definition and pull the specific x value or the a out of that limit definition. Okay, going in reverse. All right, question 4 says, for some function g, it is known that g prime of x is equal to negative 5x squared plus 7x plus 1. I'm just going to erase this because it's in the way. Find the slope of the tangent line to g at x equals 1. So if I want to find the slope of the tangent line to g at x equals 1, that means that I need to find g prime of 1. That's how I interpret it. Slope of the tangent line, g prime. At x equals 1, so I'm going to substitute 1 in for x. I'm going to say g prime of 1. This is my formula for the g prime function. So I'm going to substitute 1 into that function. I'm going to calculate. Let's see, I get negative 5 plus 7, that's 2, plus 1 is 3. The slope of the tangent line to g at x equals 1 is 3. That's what you found. B says, I'm going to erase this too so it's out of the way. B says, if g of 4 is 11, write the equation of the tangent line to the graph of g at x equals 4. Okay, so up above when we had taken our notes, we had our notes box. We had said that to write the equation of a tangent line, I need y minus f of a, so the output at our specific x value, equal to f prime of a, slope of the tangent line at that specific x value times x minus a. This time I have g's instead of a's, but the point is I need to fill out some pieces. Y minus blank equals blank times x minus 4 because that's the specific x value they gave me. Okay, well, I know that g of 4 is 11, so the 11 goes right here. That's the 11 is the output when my input is 4. But to fill this piece in right here, I need to find g prime of 4. I need to find the slope of the tangent line when x is 4. Hey, lucky for you, I have the g prime function. I'm going to say g prime of 4 is equal to -5 times 4 squared plus 7 times 4 plus 1. Oh, without a calculator. All right, let's see. We've got 4 squared is 16 times -5, I think is -80. -80 plus 28 plus 1. I think we get 51. -51. Whew. Okay. Double check my math on that, right? Okay, so that's my final answer, right? The equation of the tangent line to the g function at x equals 4. I think that's everything that we need in order for you to work on the practice. So your job is to work on the 2.3 practice. It is a front and back. Your other job for me, so there's the 2.3 practice. There's a front and a back. Use everything that we did in that 2.3 practice to help answer, or in the 2.3 lesson to help answer questions here. The other thing I need you to do, since we are a little behind, is I need you to take a look at that next lesson. It's the 2.4 lesson. I only need you to work through this front side. Now, I do have toothpicks, so if you need to borrow a toothpick, they are sitting on my desk. When it says use your toothpick tangent to trace the slopes of f of x below, that means that you're going to move your toothpick along this curve so that you can draw in tangent lines as you're moving throughout this curve. And what you're going to notice is that you get lines that look like this. I'm doing the best I can here without my toothpicks. And you're going to talk about the slopes of those lines and how the slopes of those lines are changing and at which values of x is f of x equal, is f prime of x, or no, is f of x. I think that says is f prime of x equal to 0. Yep. So you're going to go through and you're going to work through this document for me. I do not need you to do the quick notes or check your understanding. We'll talk about that when I come back on Tuesday. Okay? All right. If you have any questions, send me an email and be ready to chat with me tomorrow.